Hey guys, so today we're going to talk about transformation on functions. So when we're talking about transformations, think about the transformers. It's changing the way that it is displayed on a graph. Once we get into that, they'll make a lot more sense. So for the Nukagenda, it says the function f of x is equal to 3x squared plus 12x plus 11 can be written in vertex form as one of these. So there's a long way and there's a short way. The long way to do this is that you'd have to use completing the square. Alright, completing the square. So in order to use completing the square, what you would need to do, isolate the variable and whatnot. There's a much easier way. Use the calculator. Since it is a multiple choice question, we can go ahead and plug it in to y equals and see what we get. So let's plug in the first function and see what it is. We have 3x squared plus 12x plus 11. And while typing this, I just realized maybe completing the square would be a bit harder because the number in front of x is not 1. So it becomes a little bit more difficult there. So definitely use the calculator. Alright, I press graph, I see a graph. Now, I'm going to type in each one of these answer choices to see which one matches up to it. I'm going to start typing in number 1. So we have 3x, parentheses 3x, plus 6 squared minus 25. Press graph. That does not look like it at all. So that doesn't work. Okay, so instead I'm going to type in the next one. So I have 3 parentheses x plus 6 squared minus 25. Press graph. Nope, still doesn't work. Alright, so I'm going to type in the next one. I have 3x plus 2 squared minus 1. I press graph, and that looks exactly like it. Now, just to be sure, I can also look at the table. If both of the y values are exactly the same, I know that that has to be the right answer, because we're looking for something that's equivalent. And just to be sure, I'm going to type in the last answer. So we have plus 7. Plus 7, I press graph. And as you can see, it's actually shifting up quite a bit. Now that has something to do with transformations there. But either way, numbers 1, 2, and 4 are not the answer. Number 3 is definitely the answer. So I used my calculator for this whole process here. Okay, so now let's talk about different types of functions that we've learned. The one to do now, that's called a quadratic function. So for a quadratic function, it looks like this. We have a U shape. Alright, not too bad. The U shape, and the parent function is just y equals x squared. You can also see it as f of x equals x squared. Remember, they're exactly the same thing. Okay. Now, this lesson that we're doing, it's going to have quite a bit of graphing. Please bear with me. I'm trying my best here. Okay. Next one's absolute value function. So for absolute value function, we have a V shape. One arrow going there, one arrow going there. So we have y is equal to absolute value of x. Okay. Notice for both of these, it starts right here at the origin, or it touches the origin. I like to think of it as it starts there and then the arrows go from the side. And finally, we have radical function. So with radical functions, again, it starts at the origin and then it grows outwards like this here. So the parent function for radicals is y equals square root of x. Okay. Now, in case you forget these, you can also use a calculator. I go to y equals, let me clear these up. So x squared, the basic one, we got a U shape. To get absolute value, there's an easy way and there's a harder way to do that as well. The easy way is just press, you see where it says catalog here? It's in blue. So I press second catalog, and I press enter for the first one. I have my absolute value symbol, and I press X. I graph it, and that's what it looks like. Now notice it's a bit more stretched out on the calculator because of the screen size. And then finally radicals. So for radical, I press square root x, and as you can see, we got something like that. So these are known as parent functions. The reason why they're known as parent functions is because all of the other graphs that we have is based off of these different shapes. So for example, if I had x squared, and let's say I have x squared plus 2, x squared plus 2. I have one shape here, and the other shape is exactly the same. I'm just taking it and moving it up a bit. So let's talk a little bit more about these different types of transformations. Transformation is the change in how the graph looks. So you have one graph, this blue one here, and I changed the way it looks on the graph. I've shifted it up. We can transform functions by just looking at the equation. Quadratics, absolute value, and radical functions all have the same transformation rules. So we're going to work with absolute value functions. Let me get rid of this. So absolute value function, we have y equals absolute value of x, drawn right here. So let's figure out what happens if we have absolute value of x plus 2. So I go to y equals, and I have absolute value, so again, second catalog, absolute value of x plus 2. Notice the plus 2 is on the outside. I know I'm typing into y2, but that's okay. X plus 2. And up here I'm going to type in just absolute value of x. Absolute value, and then x. So here's my parent function, here's my new function. There's my parent function down here, my new function up here. As you can see, if you look very carefully, it's shifted up 1, 2. I'm looking at the origin because that makes it a lot easier. So the origin shifts up 1, 2. So I can write here, shifts up. I'm going to type this so it could be a little bit neater. Shifts up 2 units. Okay, so there we go. We have it shifting up 2 units. Okay, so what do you think will happen if we have minus 2? Well, let's see. Instead of having plus 2, I'm going to have minus 2. And I press graph. As you can see, the blue one is my original, it hits the origin, and then it goes down 2. So for this one, I'll write that it shifts down 2. We use the word units because we don't know exactly what the unit is. It can be 2 feet, it can be 2 boxes. We just say down 2 units. Okay. Now, those are outside of the absolute value sign. What do you think will happen if they're inside? Okay, so we have x plus 2. Now, I know that it's going to shift in some direction. These two are shifting up and down, so maybe these would shift left and right. Let's make a prediction. I say that this shifts. Since it's plus 2, I'm going to think that it's to the right. So to the right, 2 units. That's what I'm thinking, because I see that it's plus 2, it's on the inside. Since it's not up and down, because those are on the outside, maybe it's going to shift to the right 2 units. Let's see if I'm right. So, for my new function, and guys, if you have a calculator, please follow along with this. Type this in, get the practice. So inside of my absolute value sign, I have plus 2. Press graph. And it's a little bit different than what it was before. Let's just make sure. The blue one is absolute value. That's my parent function. The red one is my transform function. Take a look at that. The blue function is at 0, which is good. But it didn't go to the right 2. It actually went to the left 2. So my guess was wrong. I thought that since it's plus, it would be to the right. In actuality, inside of the absolute value or inside of any function, whether it's inside like the parentheses or inside absolute value, it's going to shift in the opposite way that you would think. So if it's positive, it's going to go to the left. And if it's negative, that means it's probably going to shift to the right then. So it's going to shift right 2 units. Since it says negative 2. And let's just take a look to be sure. So instead of a plus, we're going to put a minus sign. And sure enough, it started at 0 and then went to the right 2 units. Okay? So if it's on the outside, it does exactly what you think. If it's on the outside, and it's plus, it's going to go up 2 units. If it's minus, it's going to go down 2 units. If it's on the inside, it's going to go the opposite of what you think. Instead of, since it's positive, it's going to go left 2 units. Since it's negative, it's going to go right 2 units. Okay, that's pretty weird. Now let's see, what happens if I have the 2 outside? So I know that this operation here is multiplication. So I know it's going to be 2 times x, the absolute value of x. Now you know whenever you multiply something by 2, it gets bigger. So what does that really mean for absolute value functions? So I'm going to put a 2 in front here and get rid of all of this stuff. So I have x, and then I have 2 times, absolute value of x, and I have 2 times the absolute value of x. When I press graph, how would you describe that? Here's the blue line, our original line, and here's the red line. For me, I would describe that as it's getting narrower. So narrower by a factor of 2. Now we have to say a factor of 2 because we're multiplying by 2. It's getting narrowed by a factor of 2. So if it's half, something else is going to happen. So instead of 2, I'm going to put half. So 1 over 2. Okay. And as you can see, it's not getting narrower. We've got to figure out what's the opposite of narrower. I would say another word for narrower would, the opposite word for narrower would be wider. So it's getting wider by a factor of 1/2. Okay? So this is how we would describe all of these different functions here. And this works for absolute value functions, as you can see here. It works for quadratic functions, and it also works for radical functions. Okay? Alright, so let's go ahead and solidify this some more. So, you see the transformation rules here. Now we're using k as our constant. So instead of using 2 as a number, we're going to use k. Okay, so when we're adding, and it's on the outside, like this here, we have x squared plus 2, or absolute value of x plus 2. Whenever we're adding and that plus sign's on the outside, it means we're going to shift up. Can't spell, shift 2 units up. And if we have the minus sign, we're going to shift 2 units down. If it's on the inside of our parentheses, or inside of our absolute value sign, or inside of the radical, it's going to shift 2 units. Oops, I shouldn't say 2. I just realized that. My mistake. It's k units. Before we were talking about 2, but right now we're talking about k here. So it shifts k units up, shift k units down. So this one will shift k units, and remember, since it's plus, we want to think that it'll go right, but it's actually going to go left. So shift k units left. And for this one here, it shifts k units right. Okay? This is what we're going to be using for the whole lesson. All of this right here, it's very, very important. Please make sure to have this written down. Okay? And like we said before, if you multiply by a fraction, the graph gets wider. So if you multiply by a half or by 1/3, it just opens up some more. If you multiply by a whole number, the graph gets narrower. So it gets skinnier. Now this one we didn't really talk about, so I'm going to put a star next to that. If you multiply by a negative, okay, the graph gets reflected over the x-axis. So let's take a look at that. If I have my parent function, let's get rid of all of this. Here's my parent function. I'm going to put a negative sign, not a minus, a negative sign in front of it. Oops. Alright, well I gotta type it all in. So, absolute value, and then type in x. So if I have a negative sign on the inside, take a look. It looks like it's completely mirrored here. It looks like this is like the water, and you see the reflection in the water, straight down there. Completely reflected over. And that works for any function. Let's try x squared. X squared, and I have negative x squared. I just typed it in completely wrong. Negative x squared. There's the first one, there's the second one. So whenever we multiply by a negative, it just flips it over that line. Okay, so for the regions, you see that they'll ask questions like this. Describe the transformations to the parent function y equals square root of x to obtain y equals square root of x minus 1. So if you know your rules, you're fine. You can just use those rules. I'm going to use the rules right now. So the function shifts, now we got to see. We have 1 unit, and does it go up, down, left, or right? Well, notice that when you see this bar, it's not going over the whole equation here. If you were to use your calculator and you typed it in wrong, you would get this problem wrong. Let me show you what I mean. If I typed in square root of x, pretty simple. But if I typed in square root of x plus 1, square root of x, sorry, minus 1, this is wrong. If you look here, you see that bar? That's going over the minus 1. That's not happening here. So be very careful when you're typing this into your calculator. Instead, what you're going to want to do, you want to press the right arrow to get that out of that bar, and then type in minus 1. Okay? And here, we can see that it shifts down 1. And that all makes sense. It's supposed to shift down since it's on the outside. Shifts down 1 unit. Okay? Sometimes you can have multiple transformations going on here. Let's use the rule. I'm not going to use the calculator anymore. We can do this. So there are 2 transformations that happens here. The function. So I see that there's an 8 on the inside, plus. I got to remember, plus 8 on the inside means that it's going to shift to the left. Okay, let's go back. See the plus? It's going to shift to the left. So the function shifts 8 units to the left. And there's one more. As you can see, it's being multiplied by 2. So, since it's being multiplied by 2 and is getting narrower by a factor of 2. Okay, and that's it. We just looked at the equation. We didn't have to look at the graph to figure this out. And finally, take a look at this one. Let's take it a step at a time. So, let's see. We have a couple of things going on here. The first thing that I see that we have is this plus 2 on the outside. We know that it's going to be shifted. So since it's on the outside, it's going to go up. So shift up 2 units. The next thing that I notice is that there's a minus 3 on the inside. If it's a minus 3, let's go back really quick. Minus on the inside means it's going to go to the right. So shift right 3 units. As you can see, this is why I choose to type it out. It's so much neater. Okay, so we got this 2. We got this 3. Let's talk about the half. 3. Since it's being multiplied by a half, it means that it's going to get wider. So it gets wider. So wider by a factor of 1/2. Okay? And there you go. Now, if you thought that this was your final answer, you might be mistaken. A lot of people often forget this part right here. Let me see if I can get a highlighter. Yes. This part right here, a lot of people forget. That's a negative sign. Because there is a negative sign, we need to include that. So our fourth transformation, let me give some more space in myself there. Our fourth transformation is that it reflects over x-axis. Very important. So here we have 4 different transformations. Now if you wrote it like this, that'll be fine. If you want to write it in a sentence form, that's also fine. Either way, you're going to get the points for it. Okay. Now I want to talk about this weird way of them giving us a function. It said given a function f of x, describe the transformation of f parentheses x minus 3 plus 4. Alright, so I go to my calculator and I try to type in f of x. Where's the f? Huh. Oh, there's an f right here. See that? But I need a lowercase f. This one looks a little bit different. You guys got to be very careful. This here, they're giving you a problem where you cannot type it into the calculator. So cannot type into calculator. Very, very important. You need to know your transformation rules here. You can't use your calculator to check to see what you're doing. But it's okay. We got this. We have this plus 4 on the outside. We know what that plus 4 means. So we know that it's going to 1 shift. Since it's plus on the outside, it's going to go up 4 units. I have this minus sign on the inside. So shift, since it's minus, I know it needs to go right. So it goes right, 3 units. That's it. You're done. Doesn't matter what the calculator graph would have looked like. As long as you know what these 2 things here inside here mean, you're good. You got your answer. Okay? So whenever you see f of x, you can't type it into the calculator, unfortunately. If you see f parentheses x minus whatever, you just can't type it into the calculator. Okay, next one. It says write the equation of the graphs below. Easy stuff. Here's the first thing. I see this shape. I know that this shape is absolute value. I got abs here. Only in math. And then for this one, I see that it's a U shape, so I know that it's quadratic. Okay. So that's helpful, very helpful. I'm going to start with my parent function. I have y equals absolute value of x. Now I need to figure out what the transformation is. So the transformation, I know that generally it's supposed to start in the middle here, but instead it went down. It goes down 1, 2, 3. So since it goes down 3 units, I know that for my new function, I just have to have y equals absolute value of x. And just to be sure, when I'm going down, it's going to be on the outside of the absolute value sign. So minus 3. Minus 3. Okay, so for this one, I see that it's quadratic. I know that I'm going to start with y equals x squared. So my new function, now be careful with the square. I see that it was supposed to start right here at the origin, but it shifts over 1, 2 units. So shifts 2 units to the right. So that just means that we're going to have x plus 2 squared, right? Nah, I'm just messing with you guys. Remember, it's going right. Let's go back really quick. Since it's going right, it needs to be a minus sign. See how that's inside the parentheses? And there's a minus sign there. Be careful with that. Again, like I said, that's a common mistake. I won't be surprised if you guys make this mistake a couple of times at the beginning. But, you know, try to fix it. Don't make these mistakes on the norm. So it's x minus 2, since it's going 2 units to the right. And also, if you have a calculator, just check it out to make sure that it's right. So if I type in parentheses x minus 2 squared, there you go. It looks exactly the same. So I know that I'm right. Okay, next one. It says Richard is asked to transform the graph of b of x below. So we got this weird looking graph here. I don't know how to even graph that on my calculator. The graph b of x is transformed using the equation h of x equals b of x minus 2 minus 3. What are they even talking about here? Let's break this down. So they're saying that we have this function b of x, and it changed. It changed into b x minus 2 minus 3. Don't worry about this h of x. What they're trying to say is that h of x, that's the new function. So I'll just label this here. It just means new function. So it's a new function after it was transformed. How did b of x turn into all of this here? Oh, I shouldn't put that parentheses. How did b of x turn into b of x minus 2 minus 3? Now that's going back to that same problem that we did before, using f of x. Instead of f, they used b. So we have two things going on here. We got this minus 2. We got this minus 3. Okay. So all we need to do is describe what these two things mean. The minus 3, since it's on the outside, I like to start with that first. So the first thing is that since it's minus, it goes shifted down 3 units. And 2. Since I have a minus on the inside, minus, is that left or right? You may be thinking left, but remember, it's the opposite. It's going to go right. So shifted right 2 units. Okay? And that's it. They're asking that question in a very weird way, just to see if you understand what they're asking. All they're asking is that you're turning b of x into b of x minus 2 minus 3. That's it. Alright, I believe this is the last one here, yeah. So it says write the equation of y equals f of x after its graph has been transformed 4 units to the left and 7 units down. Okay, so we'll take our original function, y equals f of x. Now, I like to work with where it goes up and down first. It makes it a lot easier for me. So this means that I need to, since it's going down, I subtract 7 on the outside. And since it's to the left, if it's to the left, I need to add 4 units on the inside. That's it. So instead of having f of x, I'm going to rewrite this. I have y equals, plus 4 is on the inside, so I'm just going to write that on the inside. I have f. So when I say inside, I mean inside of parentheses, or inside of any function that you have. I have x plus 4. That means it's going to go to the left. And then minus 7, it's going to be on the outside, minus 7. That's it. That's all they're asking. Okay, so now you guys have some practice problems here. You guys are going to work through numbers 1 through 5. Well, that's it. Yeah, these are just describing easy stuff to do. Write the equations of the graph. Now, challenge. I definitely want you to try this challenge problem. It says write the equation y equals f of x after its graph has been transformed 2 units to the right and 8 units up. It's kind of like what we did just now. It's not that bad. I think you guys can handle it. Alright, hope you guys are doing well. Stay safe, and until next time.